Today I'll be going over the test review for for Unit 3. Target 1 will be incorporated into these first couple of problems, but we'll start with Target 2, solving the system by graphing. Remember, when we graph, we always want to have our equations in slope-intercept form, which they are in number 1. So number 1, for my first line, I'm going to start at my y-intercept, which is a positive 4. And I have a slope of positive 1. So either up 1 over 1 or down 1 to the left 1. Make sure you connect your points to make that a line. Our second equation has a y-intercept of 2 and also has that slope of a positive 1. So I'll start at 2 and graph my slope of a positive 1. These two lines never intersect each other because they are parallel. So remember, parallel lines have no solution. On number 2, we need to put these equations into slope-intercept form in order to graph them. So for this first equation, I'm going to add y over so that I have a positive y. So I have 2x equals y plus 4. And then I'll subtract 4 from both sides. So y equals 2x minus 4. So then my y-intercept is down at negative 4. My slope is a positive 2, so up 2 to the right 1. For the second equation, x plus 3y, I'm going to start by subtracting x. So I have 3y equals negative x plus 9. And then we need to divide everything by 3. So y equals a negative 1/3 x plus 3. So starting with my y-intercept at a positive 3, graph a slope of negative 1/3, so down 1, right 3, or up 1, left 3. We can see that these two lines intersect at the point 3, 2. So my solution is going to be 3, 2. To practice target 1, we would plug this point into both equations. So I'm going to plug it into the first equation. So I have 2 times 3 minus 2, and that has to equal 4. Well, 2 times 3 is 6. 6 minus 2 equals 4, so it works in the first equation. But remember, it has to work in both equations. So I'm going to plug 3, 2 into the second equation. So I have 3 plus 3 times 2, and that needs to equal 9. Well, that's 3 plus 6, which equals 9. Since it works in both equations, we know that is a solution to that system, and we can see that both algebraically and graphically. Target number 3 is solving each system by substitution, and target 4 is by elimination. You do need to make sure you use the correct method because you will only get points for using that method on your test. Substitution, our first step is to always solve for a variable. In number 3, I have y already solved for, so I'm going to take negative 6x plus 2 and plug that in for y. So I have negative 7x minus 2 times y, but we're replacing that y with negative 6x plus 2. That equals negative 9. Distribute negative 2, so negative 7x plus 12x minus 4 equals negative 9. Negative 7x plus 12x is 5x, so 5x minus 4 equals negative 9. Add 4 to both sides. 5x equals negative 5, and dividing by 5 tells me x equals negative 1. In order to solve for y then, I'm going to plug negative 1 into either of my equations. It doesn't matter which one. I'm going to plug it into that first one originally because it's already set as y equals. So y equals negative 6 times negative 1 plus 2. Negative 6 times negative 1 is 6. So 6 plus 2 is 8. So the point of intersection, if I graph these two, and my solution to this system is negative 1, 8. You can practice target 1 again by plugging negative 1, 8 into both of those equations and making sure that it works. On number 4, to start my substitution process, I need to solve for a variable. My easiest variable to solve for here is y. always look for one that has a positive 1 if possible in front of it. You know that will be your easiest variable. So y adding 4x over equals 4x plus 9. So I'm going to substitute 4x plus 9 in for y in my second equation. So I have 4x minus, make sure you put everything in parentheses because we will have to distribute that negative. 4x plus 9. And that equals negative 9. Distributing the negative sign, I have 4x minus 9 equals negative 9. 4x minus 4x cancels each other out. Negative 9 does equal negative 9, so that tells me I have infinite solutions. Okay, that tells me that these two lines, if I graph them, would be the same thing. They would be on top of each other. Target number 4 is solving by elimination. Remember, elimination, we want to cancel out one of the variables. So we want the same number but opposite sign in front of them. Sometimes you might not have to multiply your equations. Sometimes you might have to multiply one or both. On number 5, I'm going to multiply my top equation by a positive 2. This way I have a negative 6x and my x's are going to cancel out. I have minus 4y equals negative 12. Make sure you multiply everything. When I add those equations together, my 6x's cancel out. 5y minus 4y is y. 15 minus 12 is 3. So I'm already done solving for y. Y equals 3. And I'll plug that into either of my equations. I'll plug it into my second one this time. So 6x plus 5 times 3 equals 15. So 6x plus 15 equals 15. Subtract 15 from both sides, and 6x equals 0. Dividing by 6, x equals 0. So my solution is 0, 3. Again, you can practice target 1 by plugging 0, 3 into both equations. Make sure it is a solution for both of them. On number 6 here, there's not an easy way to multiply it by one number on either equation to make those cancel out. So this is one that I would multiply both equations in order to do that. We also only have all positives up there. So I'm going to multiply one equation by a positive and one equation by a negative. The top equation I'm going to multiply by negative 7. The bottom equation I'm going to multiply by a positive 8. So in the top equation I get negative 560x minus 560y equals negative 42. For the second equation here, the one that I'm multiplying by 8, I get 8 times 70, so we're going to get 500, or sorry, yes, we're going to get 560 again, so I'm going to get 560x plus 560y equals 8 times 0, which is 0. When we add these together, they're going to cancel each other out, both our x's and our y's, so I get 0 equals negative 42. That is not a true statement, so this one is going to have no solution. Moving on to target 5. Target 5 was our word problem target. We need to make sure that we write a system, so we need to write two equations here. Tickets went on sale for the Taste of Town. Parents could purchase tickets for $12, while students could purchase tickets for $9. The PTO made a total of $1,215 from the event, and 3 times as many parents went as students. How many parents and students bought tickets? Be sure to declare your variables, write your two equations, and solve. So my variables, my x and y, are always the two things that they're going to be asking for. Here they ask the number of parent tickets and the number of students. In one equation, I want to relate everything that has to do with money. So we know there's a total of $1,215. Your total is always what your equation should equal. The other two numbers relating money are our money for the parent tickets. So we're spending $12 for every parent ticket. so 12x, and we're spending $9 for every student ticket, so 9y. The other equation we're going to do has to do with 3 times as many parents went as students. Sometimes I find it helpful to make a table here, a parent and student table. So if I'm looking at my parents and I'm looking at my students, okay, if I know 2 students went and 3 times as many parents were there, then I know that would have to be 6 parents. In order to get between my x and my y, I had to multiply my y by 3. So I have 3y equals x. You may use either method, substitution or elimination, to solve from here. Since x is already solved for, I would choose to use substitution. So I'm going to have 12, and I'm going to plug in 3y for my x. So 12 times 3y plus 9y equals 1,215. 12 times 3y is 36y, so 36 plus 9y equals 1,215. And then 45y equals 1,215. So we're going to divide both sides by 45, and we're going to find out that y equals 27. Okay. I still need to solve for x, so I'm going to plug 27 into my equation. So 3 times 27 equals our x, and 3 times 27 is 81. So x is my number of parent tickets, so I'm going to have 81 parent tickets, and I'm going to have 27 student tickets. Target number 7, we're continuing to graph, but we're graphing inequalities here. Inequalities, we need to remember to use our dashed line versus our solid line, and we need to remember to shade. Looking at number 8, if I look at this first equation here, I have a y-intercept of -2. I have a slope of -1/3, so down 1, right 3, or up 1, left 3. Since the symbol, my inequality symbol, does not have an equal to, I'm going to make that line dashed. And I need y greater than. So I start at my y-intercept. I look where my y values are bigger than that, which is going up. So I know that tells me to shade everything above that line. For my second equation, I have a y-intercept of a +1. And I have a slope of -4/3. So I'm going to go down 4 to the right 3. I could also go up 4 and to the left 3. It too does not have an equal to sign on the inequality, so we'll connect it with a dashed line. And it wants everything less than, so my y values are less than going down, so we'll shade down. So the area shaded by both graphs should be this triangle here in between. To practice target 6, we would want to pick a point in the double shaded region, and we want to check it in both of our inequalities. Here I have 0, 0 in my double shaded region, so 0, 0 would be my solution I picked. And we want to try it in both inequalities. So 0 is greater than -1/3 times 0 minus 2. -1/3 times 0 is 0. 0 is greater than -2 is a true statement. Remember, then you have to try it in your second equation. So I have 0 is less than -4/3 times 0 plus 1. -4/3 times 0 is 0. So I have 0 is less than 1. That 2 is a true statement, so we know that point works for those systems of inequalities. Okay, number 9, first equation we're going to graph starts at -1 for a y-intercept, has a slope of -3/2, so down 3 to the right 2, or up 3, left 2. We need to connect this with a solid line because it has that equal to symbol. It wants me to shade everything less than or equal to y, so from my y-intercept I go down where everything is less than that y value, and we shade underneath that line. For our second equation, I'm going to start at a +3 for my y-intercept. It has a slope of a +1/2. So up 1 to the right 2 or down 1 to the left 2. It's not equal to on that inequality, so it will be a dashed line. It wants me to shade everything greater than the y, so y values are greater going up, so I shade everything above it. So this triangle over here would be my double shaded region. Again, if you want to practice target 6, pick a point out of that double shaded region and plug it into both of those inequalities. Target 8, I can add, subtract, and solve for variables in matrices. Remember, to add or subtract matrices, your matrices have to have the exact same dimension. Looking at number 10, I have a 3 by 2 matrix, and I have a 1 by 2 matrix. They are not the same size. They are not the same dimensions. Remember, they have to look exactly alike, so this is undefined. We cannot complete number 10. Number 11, I have two 3 by 2 matrices. In order to add matrices of the same size, we're going to add numbers that are in the same location. So I have -3 plus 3. -3 plus 3 is 0. I have -2 plus -5. -2 plus a -5 is -7. I have 5 plus 6, so 5 plus 6 is 11. We have -6 plus 5, which is -1. Then I have -2 plus -2. -2 plus -2 is -4. And 3 plus -1, and that is going to be +2. On number 12, I'm trying to solve for matrix C. I know when I multiply matrix C by -2, I need to get my values -16, -14, 6, and -16. So I'm going to go ahead and I'm going to divide each of these values by -2 in order to find out what C is. So C is a +8, +7, -3, +8. On 13, I'm adding two matrices, so I need to be able to add those matrices to get 2 to 13. So I like to think of each part. I know 3 plus some number in matrix Z has to equal 2. Then I know 6 plus some number in matrix Z has to equal 2 again. I also know 5 plus some number in matrix Z has to equal 13. So I can go ahead and solve these three equations and it will give me my answer for matrix Z. You do need to write it in matrix form. It does need to be a 1 by 3. So for subtracting 3, I get -1 as my first element. Subtracting 6, I get -4. And subtracting 5, I get a +8. Target 9, we are going to matrix multiplication without a graphing calculator. Remember, we have two types of matrix multiplication. Number 14 is scalar multiplication, when you just have a number in front of your matrix. We just distribute that number to everything in our matrix. So 5 times 3 is 15, 5 times 1 is 5, 5 times 1 is 5, and 5 times -6 is -30. When you want to multiply two matrices, like the rest of these problems, we need to first make sure that you can multiply them. When I look at my first matrix here, it has 3 rows and 2 columns, so it's a 3 by 2. My second matrix has 2 rows and it has 2 columns. Remember, the two numbers in the middle have to match. That tells us that I can multiply these two matrices together. The outside two numbers will tell us the size of our answer. So here I know my answer has to have 3 rows and it has to have 2 columns. I'm just going to draw this to help me divide and keep my work organized. We always will go across the first matrix looking at our rows. We'll go down the second matrix looking at our columns. I know this is my first row and it is my first column. So I'm going to multiply my first row by my first column. So I'm going to do 2 times 5 plus 2 times -5. For that, I get positive 10 plus a negative 10, so I get 0. For my second number, I'm still staying in that first row, but now I am in my second column. So here we're in our first row still, but now I'm in the second column. So I'm going to switch over and I'm going to continue to use this first row, but I'm going to use my second column here. So that means I'm going to do 2 times negative 3 plus 2 times 5. 2 times negative 3 is negative 6. 2 times 5 is 10. Negative 6 plus 10 is 4. My next value here, I am now in my second row, so I'm going to use my second row, but I'm back in that first column. So I'll use the second row of that first matrix, but I'm going to continue to use the first column of that second matrix. So I do negative 3 times 5 and 2 times negative 5. So I have negative 15 minus 10, or negative 25. I'm going to continue here to be in that second row, but now I'm also going to use that second column. So we'll use our second row and our second column. So I have negative 3 times negative 3 plus 2 times 5. Negative 3 times negative 3 is a positive 9. 2 times a positive 5 is a positive 10, so we get 19. As we continue down, we're going to be in our third row, and I'm back into my first column. So I'll use the third row of that first matrix and the first column of the second matrix. So we have negative 3 times 5 plus 2 times negative 5. So negative 15 minus 10, and again, I'm going to get a negative 25. For our last one here, we are still in that third row, but with the second column. So the third row of our first matrix, the second column of our second matrix. So I'm doing negative 3 times negative 3 plus 2 times 5, and I get 19. Okay. Number 16. In number 16, I have a 2 by 3 matrix. I'm multiplying that by a 3 by 2 matrix. My two numbers on the inside match, so that tells me that yes, I can multiply them. The two numbers on the outside tells me the size of my answer. So our answer here will just be a 2 by 2 matrix. So again, I'm in my first row, first column, so I'm going to multiply my first row by my first column. So negative 3 times 1 plus 3 times negative 5 plus 4 times 0. So I have negative 3 minus 15, so I'll have negative 18. I continue to be in my first row, so I'm going to continue to use this first row, but now I'll be in the second column. So negative 3 times 1, 3 times negative 2, and 4 times negative 2. So 3 times negative 1 is negative 3, minus 6 is going to be negative 9, minus 8 is going to be negative 17. Going down, I'm now in my second row, so I'm going to use negative 6, 4, and 3, 1, negative 5, and 0. So negative 6 times 1 plus 4 times negative 5 plus 3 times 0. So I have negative 6 minus 20, negative 26. Last one, we're going to use our second row still, but now we're in the second column again. So negative 6 times 1 plus 4 times negative 2 plus 3 times negative 2. So I have negative 6 minus 8, which is negative 14, minus 6 gives us negative 20. Last but not least, on number 17, I have a 1 by 4 matrix. We're going to multiply that by a 2 by 3 matrix. But I notice these two numbers don't match. That tells me I cannot multiply those two matrices together. Target number 10 and target number 11, you are going to need to use a graphing calculator for. Target number 10, we're multiplying our two matrices in the graphing calculator. So the first thing, remember, we need to do is put the matrices into our graphing calculator. In order to put the matrix into the calculator, we're going to hit second matrix. We want to scroll over to edit. My first matrix here is going to be a 3 by 1, so 3, enter, 1, enter. And then we need to plug in our numbers. So -6, make sure you use the negative button. So -6, enter, 4, enter, 6, enter. We have to quit out of here to put our second matrix in. So we hit second mode to quit out. And then we go back into second matrix, scroll over edit to put in our second one. Make sure you put your second one not in A. I would just go ahead and use B. If I look at matrix B here, matrix B is a 1 by 3. We have 1 row and 3 columns. We have -3, 6, and -3 again. Make sure you quit out of your matrix. So we're going to hit second mode. Then we go back into our matrices. When I want to multiply them, I don't scroll over to edit. I hit enter on A. Then I go back in, second matrix, scroll down to B, hit enter on B, hit enter again, and it will give us our answer, which is a 3 by 3. Make sure you copy those numbers down. So we have 18, -36, 18, -12, 24, -12, -18, 36, -18. Number 19, we again have two matrices to multiply together, so we need to enter them in. So second matrix, scroll over to edit, and hit enter on A. Our first matrix there is a 4 by 2, so 4, enter, 2, enter. We'll plug in our values. So we have 4, -6, -2, 2, 2, -3, 4, and -4. Quit out of that. Go back to matrix. Scroll over to edit. This time I'll go down to B. So matrix B here is a 2 by 2 matrix. We have 2, 4, 4, 3. Quit out of that. Again, to multiply, we go second matrix, hit enter on A. Do not go to edit. Second matrix, hit enter on B. Go ahead and hit enter, and it gives me my answer. So -16, -2, 4, -2, -8, -1, -8, and 4. We're going to continue using the graphing calculator to do target 11. Target 11, we're going to solve them by graphing. To graph, remember we use that y equals button in the top left. Go ahead and clear out any equations you have there already. I have -1/2. Again, make sure you use the negative button. For 1/2, we'll do 1 divided by 2, x plus 1. My second equation is x plus 4. Hit the graph button. You should have two graphs on your screen. To find that intersection, we're going to hit second trace. Number 5 for intersect. We'll hit enter 3 times. First curve, second curve, guess. Hit enter. And our answer is -2, 2. For number 21, the first thing we need to do is put these into slope-intercept form so that we can graph them in our calculator. On the first one, I'm going to subtract 5x over and then divide everything by -3. So y equals a positive 5/3 x minus 4. The second equation, we just need to subtract x over. So y equals -x plus 4. Going back to my graphing calculator, I'll hit the y equals button. I'm going to clear my equations out. So the first equation I have is 5/3, so 5 divided by 3x minus 4. My second equation, I have negative x plus 4. Go ahead and hit your graph button. Do second trace number 5, and we'll hit enter 3 times. So my intersection here is at a positive 3, positive 1. Okay. Going on then, we won't need our graphing calculator anymore. We're going to start our linear programming targets. Target number 12, we were just testing our vertices to see which is a max and a min. On this one, I have 3 vertices to test, so I'll test 0, 4, 3, 5, 0, 0, and 3, 0. Remember, we are testing these in our objective function, so I'm going to plug them in for x and y. So I have 0 plus 3 times 4, which is 12, 3 plus 3 times 5, 18, 0 plus 3 times 0, 0, and 3 plus 3 times 0, which is 3. So we look at these numbers to find out which is our max and our min. Our min is always the smallest one, so my minimum value is 0. It is at, we got 0 at the point 0, 0, so at 0, 0. My maximum value here is 18, and I got 18 at 3, 5. So those would be our min and max for that problem. Looking at the second one, I again have 4 vertices, negative 1, 2, 2, 3, 6, 0, negative 2, negative 1. Again, we're going to be plugging them in to our objective function. So 3 times negative 1 plus 5 times 2 gives me 7. 3 times 2 plus 5 times 3 gives me 21. 3 times 6 plus 5 times 0 gives me 18. And 3 times negative 2 plus 5 times negative 1 gives me negative 11. So my minimum value here is negative 11. Happens at negative 2, negative 1. 21 is my maximum value, and that happens at 2, 3. Target number 13, we're going to have to graph in order to find out where our vertices are and test them in that objective function. So remember, our objective function up here, we do not graph, but we will have to graph all 4 of our constraints. X is greater than or equal to 0 is going to be our vertical line at x equals 0. We're going to shade everything to the right because we want everything greater than or equal to it. Similarly, if we look down, we also have y is greater than or equal to 0. So that's going to be where y equals 0, and we're going to shade everything above it. We also have x is less than or equal to 3. So I go over to 3 on the x. Everything has to be less than or equal to, so we're going to shade everything to the left of that. Our last equation we have is y is less than or equal to 5, so I'll go up 1, 2, 3, 4, 5. And everything has to be less than or equal to that. So my area shaded by everything is this rectangle over here. So I'm going to have 4 vertices that I need to look at. So one of my vertices is there at 0, 0. I have one at 3, 0, 3, 5, and 0, 5. We'll plug those into our objective function up top. So I have 0 plus 0, which is 0, 3 plus 0, 3, 3 plus 5, which is 8, and 0 plus 5, which is 5. So our minimum value here is 0, and that happens at 0, 0. Our maximum value here is 8, and 8 happens at 3, 5. We scroll to the bottom. Again, our objective function we won't graph. So I'm going to start with x is less than or equal to 0. So we have a vertical line at 0, and we're shading everything to the left of it. Then I have y is less than or equal to 4. So we want everything less than 4 for our y values. Our last equation, we need to put that into slope-intercept form, so I'm going to subtract x. So y is greater than or equal to negative x minus 1. So my y-intercept is at negative 1. I graph a slope of negative 1. So down 1, right 1, or up 1, left 1. Go ahead and connect those points, and it wants everything greater than or equal to it, so we're going to be shading above it. So in this little triangle here is where we have all 3 of our shadings. So my 3 vertices there, I have one at 0, negative 1. We're at 0, 4. And then our last one here is at right there, so we're at negative 5, positive 4. Plug those into our objective function, which is x minus y. So 0 minus a negative 1, or 0 plus 1 is 1. 0 minus 4 is negative 4. Negative 5 minus 4 is negative 9. So my minimum value is negative 9. That occurs at negative 5, 4. My maximum value is 1, and that occurs at 0, negative 1. Our last target of this unit is target 14, so that puts together targets 12 and 13. The Elite Pottery Shop budgets a maximum of $1,000 per month for newspaper and radio advertising. The newspaper charges $50 per ad and requires at least 4 ads per month. The radio station charges $100 per minute and requires a minimum of 5 minutes of advertising per month. It is estimated that each newspaper ad reaches 8,000 and each minute of radio advertising reaches 15,000. The combination of newspaper and radio advertising should the business use in order to maximize the number of people. So let's start with our variables. The 2 things they are looking for is what combination of newspaper and radio advertising they should use. So I'm going to do my x as newspaper and my y as radio. When you're looking at your objective function, we're always looking at what they want to maximize or minimize. Here they tell us they want the maximum number of people. So we're going to use all the numbers that relate to people in this. So we have 8,000 for our newspaper, and we have 15,000 for the radio. Newspaper is my x, so I have 8,000x. And my radio advertising is 15,000, and radio is my y. So that'll be our objective function that we're going to plug our vertices into at the end. We also need to find our constraints, so the rest of these numbers are going to lead us to our constraints. They budget a maximum of $1,000, so we know we can spend $1,000 or less. The newspaper charges $50, and the radio charges $100. So I'm looking for everything that deals with money. So newspaper is 50, so I have 50x, plus my radio station is 100, so 100y, and that has to be less than or equal to my total budget, which is 1,000. They also tell me that the newspaper charges $50 per ad and requires at least 4 ads per month. So my x, or my newspaper, has to be greater than or equal to 4. Similarly, they tell me that for the radio, there's a minimum of 5 minutes. So I know my y is greater than or equal to 5. Go ahead and graph those equations. That first one I need to put into slope-intercept form in order to graph, so I'm going to subtract 50x. So I have 100y is less than or equal to negative 50x plus 1,000, and divide everything by 100. So we have y is less than or equal to negative 50 divided by 100 is negative 1/2 x plus 1,000 divided by 100 is 10. So my y-intercept is up at a positive 10 with a slope of negative 1/2, down 1, right 2. And connect that with our line. And they want everything less than or equal to that, so that tells me that I'm going to shade everything underneath that. Then I need x greater than or equal to 4, so 1, 2, 3, 4. I need all my x values to be bigger than that. And then y has to be greater than or equal to 5. And we want everything bigger than that. So the area that I'm going to use, because it is shaded by all three, is this purple triangle. So I need to find the 3 vertices that create that triangle. So right here I know I'm at 4, 5. Then I'm at 4, 8. Over here I'm at 10, 5. So we'll test those vertices by plugging them in to our objective function. So I have 4, 8, 4, 5, and 10, 5. My objective function that we found was that 8,000x plus 15,000y. So I'm going to do 8,000 times 4 plus 15,000 times 8. Plug that into your calculator. And we get 152,000. And we'll do 8,000 times 4 plus 15,000 times 5. And we get 107,000. So we have 8,000 times 10 plus 15,000 times 5. And that gives us 155,000. They asked for the maximum, so our maximum value is 155,000. That happened at 10.5, and we know in this context 10 is our x, so that would be 10 newspaper and 5 for the radio.